In this video, we're going to explore two instruments that can be used to determine the diameters of circular objects, which in turn can help us determine the circumference of these circular objects if we wanted to. Now, there are different ways in which we can measure the diameter or the circumference of a circular object without having to use really fancy instruments. One method is using a string. So let's say, for example, I wanted to measure the circumference of this coin. I can take a piece of string and I can roll it around the circumference of this coin. I can cut it off here, and then I can take this piece of string and lay it on a ruler to see how long it is. Now, this is not the most accurate or precise way to measure a circumference, but sometimes you don't need to be extremely precise. Just a close enough number is good enough, right? Another way to calculate the circumference of an object is to grab a ruler and measure its diameter. So you can put it straight here or on the side, measure the distance from the highest point to the lowest point, and that gives you the diameter. And then you can use the circumference formula to find the circumference. You can just multiply by pi, the diameter by pi, and you get the circumference, right? And again, this is more accurate than the method we used before, but it's still not the most precise method, and that's totally fine. So, even though those two methods are acceptable for certain jobs or certain purposes, such as constructing engines for cars and airplanes, measurements have to be taken a lot more precisely. Otherwise, these engines won't function properly, or sometimes they won't function at all. So in those specific cases, we need to be precise. And keep in mind that the more decimal points we take in an answer, the more precise our measurement is. So for example, a measurement of 2 centimeter is not as precise as 2.125 centimeters. This one is more precise. And if you go on to take Math 30-3, we actually delve a lot more deeply into what precision is and what accuracy is. But for now, we're just going to talk about two instruments that we can use to get these precise measurements. One of them is the Vernier caliper, and the other one is the micrometer. So the first one here is the caliper, and this one is the micrometer. In this video, we're going to talk about this only. Okay? Your book also goes through how to use a micrometer, so I highly recommend that you look through that. I will also link some videos with demos on how to use both of these so that you can see them as they're used in real life. Because you'll notice that the examples I'm going to give you in this video are flat representations of what a Vernier caliper is, and that's not how we see it in real life. Okay? So I highly suggest watching those bonus videos on what it actually looks like in action, especially if you're interested in doing any construction, carpentry, any type of job that requires taking accurate measurements. I recommend that you watch those videos. Okay, so now let's look at the Vernier caliper and the different parts of it and how to use it. All of these diagrams and steps are from your coil book, so feel free to read through that as well. You don't need to take notes of everything here. So this is our Vernier caliper, and it's made up of different parts. We have the outside jaws and the inside jaws. We have the Vernier scale. So this one right here, this one actually moves along the Vernier caliper. So sometimes it's referred to as the moving scale. Then we have this scale right here, and it's called the fixed scale. And then we have the depth gauge. Okay. Now, here I explain what each of those does, so you can pause the video and read them. But I'm going to explain them verbally right now as well. So the outside jaws, they go on the outside of a circular object. So let's say I have a pipe and I want to know the diameter of this pipe. I would put these jaws on the outside of the pipe and then tighten them so I can take an accurate measurement. The inside jaws go inside a circular object. So again, let's say I have a pipe. These would go inside the pipe, and then I would widen these to make sure that they fit snugly inside the pipe. Okay? The depth gauge would go inside a cylinder, would go inside to measure how deep it is. Okay? Now I'm going to go to the next page, which has the same diagram, but this time we're going to look at the scales. So we have two scales. We have a moving scale or a vernier scale, and we also have a fixed scale. Now, what you have to be mindful of is what type of units are used in this caliper. So in this example, in this diagram, they're using SI units, so centimeters and millimeters. The fixed scale here is in millimeters. So if you notice, every line here represents 1 millimeter. Okay, you can also say that it represents 0.1 centimeters. Both of them are the same, really. Okay. And then we have the moving scale or the vernier scale, and this one is even more precise, and it's in 0.1 millimeters or in 0.01 centimeters, same thing. So basically, if we use this vernier caliper to take a measurement, we're going to have some measurement here, dot, a number, and a number. Okay? So we will have 2 decimal places, and this is if we represent our answers in centimeters. Okay? So now that we've talked about that, let's go over the steps on how to use a vernier caliper. I'm going to go through them verbally, and then we're actually going to solve a question together. Okay? That way we're applying what we're learning. So again, the steps are right here. These are from your book. You can pause the video and read them, but I'm going to go over them with you right now anyways. So the first step is for you to fit the vernier caliper on your object. By the way, we have several of these at the Spruce Grove Outreach. So if you'd like to come in and try them out, you can definitely do so. So let's say I'm using the outside jaws and I have, let's say, a can of soup, and I want to know what is the the diameter of this can of soup. So I'm going to fit it inside, and I'm going to tighten the jaws here, and now I'm ready to take my measurement. The first thing that I'm going to do after I've secured this part is I'm going to look for the first line on the vernier scale, and that is this one right here. I'm going to draw it in red so you can see it better. This one. You see that? So this tells me the number before the decimal point. So here this is 2, 2.1, 2.2, 2.3, 2.4. So this is 2.4. Okay? Now, I'm going to figure out what the next decimal point is. And for that, I'm going to look at the rest of these numbers. And what I'm looking for is a line from the bottom and a line from the top that line up perfectly. That means I'm not looking for a line like this and a line like that. I want the line from the fixed scale and a line from the moving scale to be perfectly aligned. And that's what's going to give me this the second decimal place. Now, I'm not actually going to demonstrate that right now because it's hard for me to see, but I'm going to take you to an example where we can actually apply that. The example takes a snapshot of a vernier caliper right around here. Okay, so we're just going to look at this part of the vernier caliper. Okay, so there it is. So you notice how we're just looking at the scales here. Now, in this example, we are looking for a measurement. So this one right here, this is the vernier scale. This is the moving one. And this top one right here is the fixed scale. Okay, so to determine the first number, I'm going to look at that first line on the vernier scale. And I'm going to look at what position it's in. So here I am at 2 centimeters. This is 2.1 centimeters. This is 2.2 centimeters. And this line is between them. So my measurement is going to be 2.1 something. Okay? Because it's between the 1 here and the 2 here. Now, to figure out what that second number is here, I'm going to look for, and let me just delete these marks so you can see better. I'm going to look for 2 lines, one from the bottom and one from the top, that match up perfectly together. So let's look at this one. This one does not line up with anything. This one doesn't line up with anything at the top. This one is close to this, but they're not lined up. Let me just go back a bit. There we go. This one is getting closer to this, but they're not lined up. But look at that one. They're perfectly lined up. So this is the one that we're going to look at to find that measurement. And how do I know what that number is going to be? Well, I basically count from here. This is 1, so 0, 1, 2, 3, 4, 5. This is 5. So this number is 5. So our measurement is 2.15. Okay? A little warning here. When we're reading measurements, I notice that a lot of students make mistakes in this part of the solution, is they start counting from here. You're not counting from here. Remember, you're counting from the 0. You start there. Okay? So, this is just explaining what I already did. So this is where you start at 2.1, and then these two line up, and you count 0, 1, 2, 3, 4, 5, and that's how you get that answer. Okay? So now we are going to look at some examples, but those will be in the next video.